Welcome to my YouTube channel, a Brainery of Civil. Today I am going to explain you about the second assignment of Advanced Concrete Technology. Obviously, this is a theory topic. Let's have a quick discussion on this topic. The first question, as per the EN classification for type 3A cement. So that is type 3A cement. We can use extenders up to 65%. But the only allowable extender is, obviously according to EN classification, it has allowed in type 3 cement up to 65% of extenders. So, but it allowed only slag is the extender. Clear? It should not allowed any other material except slag. Clear? In type 3 cement. Next question. Technique used to study reaction rates of cement particles. Obviously, calorimetry. Calorimetry is the very important technique used to study reaction rate, that is rate of reaction of cement particles. Okay, so answer is C for question number 2. And next question. During the cement hydration, the viscoelastic mix. Viscoelastic mix is nothing but it is in the form of a paste. Transforms to a solid, rigid solid after the final set. The statement is true or false. Obviously, for question number 3, whenever during the hydration of cement, viscoelastic transformed into a mix one. Obviously, immediately after mixing raw materials and water, it will form some paste material. After that, it will get converted into rigid solid, and again it's grinded, gets into powder form like a cement. Okay, so this is a true statement. Next question. As per EN classification of strength classes, 32.5 Newton compressive strength. Compliance should be checked at the edges of the most important question. Here, the option given with this mark. If the options were this type, then it is the indication of multiple answer questions. They are not related to something like rounded one. If they are of square boxes, the options, you can tick more than one answer. Okay, so from past 2-3 years onwards, there are 2 to 3 questions in the GATE examination are of multiple question answers. Okay, these type of questions generally they are in the IIT JEE exam, but recently they have included in GATE exam as well. So for this question, the strength of the concrete or cement paste is checked generally at 7 days as well as at 28 days. Okay, so that is the answer for question number 4. So it is having 2 answers, not only one answer. So that is the indication they were given. Next question. The decreasing order of heat of hydration of pure cement compounds are, obviously in cement there are 4 box compounds, C3S, C2S, C3A and C4AF. Out of all these 4 box compounds, the heat of hydration will be maximum for C3A and C2S will have low heat of hydration and it is maximum. After C3S, after C3A, C3S will be produce maximum heat of hydration. I am writing here C3A will produce maximum heat of hydration. After that it is C3S. After that it will be C4AF. After that it will be C2S. So that is to produce low heat cement. In out of all the 4 box compound, which compound is giving low heat? It is C2S. That is, if we need to manufacture the cement of low heat, we need to provide more quantity of C2S in that particular cement. Okay, that is low heat cement. Okay, so the answer for question number 5 is B. And next question. as proposed by Borg, approximately half of the total heat of hydration in OPC is evolved in, for example, out of 100% of heat of hydration during concreting or during cementing, how much heat of hydration will be liberated in first 3 days? So they can ask from question to answer or answer to question. So within 3 days, half of the total heat, that is, statement is very important. Within 3 days, half of total heat will be liberated okay, clear? So the answer will be between 1 to 3 days, half of the total heat will be liberated. And now coming to question number 7 and 8. These are all the questions are related to same. Obviously, in isothermal calorimeter, which is measured, so either heat or temperature. So heat will be measured in isothermal calorimeter. Isothermal means it is having temperature constant. So the next question is, in isothermal calorimeter of system maintained constant, that is temperature of the system is maintained constant. By maintaining the temperature at constant value, we need to measure heat, okay, by using isothermal calorimeter. And next question is, in the heat evaluation curve for Portland cement, the peak 3 or shoulder peak after the main peak occurs when, that is, for example, this is main peak and then this shoulder peak. So this is main peak, this is shoulder peak. So this shoulder peak observed when there is a formation of ettringite from C3A compound. Okay, so whenever there is a chance of getting ettringite from C3A compound, so you can observe this type of peak. That peak we call it as peak 3 or shoulder peak. Okay, so the answer is this is whenever there is a conversion from ettringite to monosulfate, then peak 3 will be formed. So for question 9, answer is not C, it is answer D. Okay, so when there is a conversion from ettringite to monosulfate, so the answer will be D for question number 9. And next, the strength attainment in a hydrated cementitious system can be judged by using data. Obviously, the amount of heat generated or amount of heat liberated will indicate the attainment of the strength. For example, today the concreting was done. For example, today X1 is the heat liberated. That is, we got an amount approximately X1 strength. Tomorrow X2 is generated. The cumulative amount will become X1 plus X2. And day after tomorrow X3 amount of heat. So on that day cumulative will become X1 plus X2 plus X3. So finally strength will become X1 plus X2 plus X3. Clear? That is, it is cumulative amount of heat by the time will indicate the attainment of the strength at the same time. Okay, so it is not just heat developed at the time, it is cumulative until then. So the answer for question number 10 is C. And he has given two statements. Reducing water cement ratio reduces peak temperature of hydrating cementitious system. Obviously, whenever water cement ratio reduces, So reducing the water cement ratio reduces peak temperature. So this is a false statement. One is false statement. And the dormant period of hydrating cementitious system can be increased by increasing water cement ratio. That is, dormant period increases when water cement ratio is high. Okay, so that is, if we reduce water cement ratio, heat also will be reduced. So for that reason, question number statement 1 is wrong, statement 2 is correct. So the answer is B for question number 11. And coming to the final question, increasing levels of fly ash replacement. So that is, in ordinary Portland cement, we are adding some amount of fly ash. Okay, so then what it will result? Obviously, lower rate of heat of hydration and increases dormant period. That is when fly ash content is added. Rate of heat evolution decreases, dormant period increases. So what is the dormant period? Dormant period is the time required to liberate the heat. So that is time required to liberate heat for hydration process. So that is, if we are adding fly ash into the cement, so it will reduce the heat of hydration. Whenever it is reducing heat of evolution, so the heat will be liberated very slowly. So obviously that means dormant period will increases. For example, in ordinary Portland cement, within 3 days 50% of heat will be evaluated. But if we have replaced some amount of cement with fly ash, so it will not completely relieve its heat within 3 days. It will take 7 to 10 days. Obviously, it will be more than 3 days. Okay, so that is, in earlier case, for 50% of heat evaluation, dormant period is only for 3 days. But in now, after replacing some amount of cement with fly ash, dormant period became more than 3 days, approximately 7 to 10 days. It depends upon the amount of fly ash that we have replaced. Okay, I hope you got the meaning of dormant period. So for question number 12, answer is C. So this is the final question for this assignment, and I hope you like the way I have explained. Please share to your friends and get benefit. Thank you.